we're going to be starting our new internal, which is called networks, and this is kind of a fun one, really, and that might not seem like mathematics for some of it, but it really is. And if you're thinking about where this might work in like a practical, real-life situation, something that's really relevant for us in Christchurch is kind of traffic engineering and city planning to figure out new bus routes and the ways to work the roads, given all the changes and closures and things that have been happening, or even the new bus exchange would use some of the skills that we are cover here. So it's kind of about, in a very simplistic way, thinking about just solving mazes. So for instance, if I wanted to get between every single one of these nodes or points, I could do that by following a path around. And there's probably more than one way to do it. You know, I could go this way as well, and I could get to every single node. So networks is kind of about finding the best path between all the different points that are available, or sometimes just the most direct route between two different points. So we'll take a look at this, and just the basics to start out with would be some vocabulary. So a few things that are important for us to know. One of them is the vertices, or the vertex point here. These are nodes. You can think of these like bus stops or houses or things like that. So you might refer to them as node, but you might also hear them referred to as a vertex. An edge is the line that connects two of these vertexes, so the edges go around, and then the whole thing is basically a network. Another one for us is really important is the degree, so the degree of a particular node. And what this is looking at is that we want to count how many edges go in or out of a node. And sometimes I also like to think about it as just how many edges, kind of like kebab sticks, stick into the node. So this is degree 5 on this particular node as an example, because I have 1, 2, 3, 4, 5 sticks basically poking in to that node. Even though one of them is just the top and bottom of the same path, the same edge, I still have 5 poking things into that node. So 5 different holes poked in that node, so it would be degree 5. Versus all these other ones are degree 3 because they each only have 1, 2, and 3 things actually sticking into them like kebabs. So that's the idea of degree. And one more quick thing to point out about how these networks work is that you have to travel around the edges. You have to travel along the edges. So you can't go from here randomly over to this edge. You have to stay on the edge. And you can only swap from one edge to a new edge at a node. So as an example here, if I'm going from from D to B, that's my only option. Even though I'm crossing past another edge here, it's an illegal move for me to go like this and swap over to the next edge. So you can think of these as like roads, and without a node in between, it's kind of more like an overpass, as if the path A to C is actually skipping over the path, like maybe the Colombo Street Bridge or something. It's that idea when there's no node, you cannot switch paths. So we cannot swap the edge we're traveling on, I guess. Unless you have a node. So unless you are at a node. So keep that in mind. If there's no vertex there, if there's no node there, you have to stick to the edge that you're on, the path that you're on, until you get to your node, and then you can change directions.